Hello and welcome to the very first statistics video, 1.1 displaying categorical data. Since it's the first video, quick rundown. So these videos are totally for you to be able to fill out this note taker at sort of whatever pace makes sense for you and sort of in whatever sequencing that makes sense for you. So if you find yourself needing to pause, pause. If you need to rewind, rewind. If you can watch this at 1.2 speed and still get it all, do that. If you need to slow it down to like 0.8 speed, do that. Come back to these later on. You don't have to just watch it one time and be done. Feel free to view these as many times and in whatever order and whatever chunks you need throughout the whole year. That's what they're there for, okay? So why don't we get into it? We're talking statistics. In statistics, there's two buckets of variable. There's categorical variables. So you can read the definition there, but essentially it's the idea that these are, little groups within a category, not necessarily things you measure. Things that you measure are quantitative. These are numbers. Quantity means a number that has some sort of in special units. So examples of categorical might be something like hair color, or your first block class. You can't represent hair color necessarily with a number here. You're going to talk about black, brown, blonde. First block, you're not going to really talk about it in terms of a number. You're going to say it's bio, it's statistics, those sorts of things. But over on the other side, quantitative, you do talk about with numbers. So if I asked you your height, you probably would respond with a number. Or your weight, you would respond with a number. So those are some pretty common ones there. So I'm going to ask you some things that I want you to think about and write it in the boxes where you think they belong. And we're actually going to talk about those in class. So come prepared to sort of defend your answer. And before we get into it, one of the common things that you should think about is just because something is a number doesn't always mean it is quantitative. An example of something like that might be like your student ID number. Even though it is a number, it really wouldn't make sense to call it like a number that is a quantitative variable because it really doesn't have any units attached with it, and it doesn't really act like a number in the sense of like how height and weight do. So a good rule of thumb is like if something is a number, but you're like, does it actually make sense to think of this as a quantitative variable? Then I always like to think about like, does it make sense to find like the average of a group of these numbers? And does it mean something to me? Average height makes sense. Average weight makes sense. But if I grabbed like the class and I took the average student ID number from all of you, I'm not sure that helps me understand you as a group any better than before. So here we go. Here are some different ones. Think about it. Plop it into the appropriate boxes. I'll write them down here in the middle for you. So how many hours of sleep you got in the last 24 hours? Where do you think something like that belongs? Or related, but maybe different here. Did you get at least 6 hours of sleep? Did you get at least 6 hours of sleep in the last 24 hours? What do you think that would be, categorical or quantitative? How about your zip code? And then lastly, how about the number of stars for a review on Amazon, an Amazon product? So you bought something, they're like, hey, review it, and you ranked it, 1, 2, 3, 4, 5 stars. What do you think that would belong in? So if you need more time, pause and think about those more and really think about why you're putting them in the places they are. And you're going to come in and talk about them, and don't feel like you have to be right about these four. If you misplace something, that's a learning experience. All right, so we're going to focus mostly on categorical variables here for this particular notes. And so we're going to talk about how you display them. There are 6 different ways to display these things. First, we'll talk tables. So tables are pretty common to use here. So the data I'm looking at here is, this is like, I think 3 or 4 years ago, the number of students that graduated from Fremont High School where did they head off to? What was their destination after graduation? Four-year university, two-year college, or doing something else? So first way that you can organize that is a frequency table. You see it right there. It's got the raw counts for you for each of those three groups for the category of post-graduation destination. Something that they might not do in the future for you here is give you a total row. They didn't give us one here, and in the future you might not get one either. I always like to sort of total it up, because oftentimes that becomes valuable to us in other things. It also just kind of gives you an idea of like, how many people are we really talking about here? So you calculate it all up here, and what you end up with is 433. If you want to pull out a calculator and verify that, you can, but I can do the math for us if you don't have your calculator yet. So a relative frequency table is very much like a frequency table, except for it's going to be talking about proportions or percentages instead of the raw count. Okay, so it sort of gives you an idea of like, oh, what percentage of the people did this thing or that? Or so here, it's a really easy calculation for four-year university. We're going to go 190 divided by 433, and that's going to give us 43.9%. You could have called it 44% if you like rounding to just a whole percent. That's totally fine. Two-year college, that's going to be 156 divided by 433, which gets us 36%. So a little over a third of people graduating from Fremont will go into a two-year college. Last one, other, that's going to be a 20.1%. All right, and again, you can do a total here, and when I total it up, no surprise, it totals up to 100%. Although, disclaimer, sometimes because of rounding, when you total it up, you might get 99.9% or 100.1%. That's okay. Like, if your rounding caused that little hiccup in there, it's not a big deal. You don't have to go and find a way to fix it or anything like that. Just go along with it. It happens sometimes, okay? All right, so then now let's talk about charts. Those are tables. Tables are nice. Charts are also nice. You get a sort of a visual there. So we'll start with the most common one, a bar chart. You can see that the bar chart is essentially the frequency table above it, just in a bar chart form. You're just taking these raw counts and you're making a different bar for each sort of group in the category. And you're just going to make the bars as high as they need to be in order to represent those raw counts. You'll also notice very well labeled here. At the bottom here, you see that I have destination in there. That's the category, the variable we're talking about. And then I have the three different groups written in there as well. So that's always an important thing, is to really well label stuff. I also put in the raw counts along the top there. I like to do that to just sort of represent them, so that it's a quick visual. I don't have to have somebody sit there and spend time looking at it and going like, is that 155 or 156? You know, so. So let's go ahead and do now a relative frequency bar chart. You might be able to guess that is just taking the relative frequency table from above and turning it into a bar chart form. So we need to first label the axes here. I got already sort of the labels down below, but we need to scale the vertical axis. I need to get up to beyond 44% here, essentially. And looking at this, I'm just going to go by 10. So I'm going to go 0%, 10%. So scale along with me. And then I'm just going to make bars that sort of match up with those things. So for the four-year university, it was about 44%. So I'm going to go in here and make a 44%, like so. If you want to grab a ruler and make it nice, you can do that. I have like a little thing that clicks to straight lines for me on my iPad, so that's nice. And then I'll stick with the sort of the same motif as over there. It's got these little slash lines in it. And then at the top, I'll go ahead and write 44% or 43.9%. Like I said, it's okay. Why don't you go ahead and start filling in the other ones while I'm doing it as well. Next one, we're going to go 36%. Another thing you can also do instead of different patterns is obviously grab different colors if that was something you were interested in. So that's what your relative frequency bar chart should look like. If you need more time, pause the video and do that. But quick note, notice how it effectively just looks like the bar charts. Like the heights are, similar to each other. Yeah, the scaling's a bit different on the y-axis, but in relation to each other, the bars look the same. That should make sense. All you did was take these raw counts and divide all of them by 433. So like the relative look of these things would be about the same. Now, a segmented bar chart is also sometimes I think called like a stacked bar chart. Essentially what it does is it takes this relative frequency bar chart and it stacks each of those bars on top of each other, which means that the total would get up to 100%. So now when we go to scale, I'm going to go by 20s instead. And then I'll go ahead and draw in these different bar charts to these different heights. So the first one, I'm going to go ahead and go a big bar here up to about 44%. And so that one's going to represent the 4 year. So I'm going to go over here. I'm just going to go ahead and label it 4 year, 44%. And then we're going to stack the 36% for the 2 year on top of that. What's nice is you can just sort of add together 44 with 36 to sort of see where your stopping point is. So I'm going to get all the way up to 80. So I'm going to go ahead and draw a line up to 80 like so. And shade that one in. Like I said, maybe this one's a good one to do different colors with if the different patterns aren't really working for you. Although if you are colorblind, perhaps it is working for you. And then the last little bit for the other, that's the 20%. Notice how that gets us up to 100%. Ooh, that got a little bit sideways on me, but that's okay. That's the main idea there, a little bit slanty. So yeah, segmented bar chart. Like I said, it's just the relative frequency bar chart where you stack everything on top of each other. I kind of like that one, as it's sort of looks nice and visual and kind of gives you an idea. It just is a little bit tougher for comparing. Like it's nice to be able to look at like the relative frequency bar chart and really quickly see that like, oh yeah, like 2 year compared to 4 year, isn't vastly different. It becomes a little bit tougher maybe to look at the segmented bar chart and see that just immediately. And so one last chart that we sometimes see that you'll never have to create is a pie chart. I won't go over this too much because I'm sure you've seen these plenty. They're in the news plenty. Sometimes they're misused. But ultimately, this is a pretty common chart that you see. It is essentially the segmented bar chart, just in circular form. You get to see the different percentages. It's nice to always have like a little legend or key or things clearly labeled to make sure that that happens. But you'll never have to make one of these because it's just impossible to make them accurately. So we let the computer do it. So you might be thrown one, have to read some information from it, but you'll never have to make one. All right, we're going to move to the backside now. If you need to pause and catch up, do so. But let's look at the backside. The backside has us looking at the Titanic. The Titanic sunk in 1912. There's a common phrase, women and children first, that is associated with the Titanic because when the Titanic sunk, there wasn't enough lifeboats, so women and children were given priority. You can see the percentages there about how men did or did not survive at certain rates. What I want to sort of look at now is whether the class that they were in, sort of where they were on the boat, how that affected their survival rates here. So first class, second class, third class, and crew members, you can see that there's the 4 groups, and they have over here the number of people who survived. What would you say to someone who said that first class and third class passengers survived at about the same rate? What would you say to that person? So hopefully you would say something like, I don't know how you would determine that from this little chart that we're looking at. Now, perhaps they're looking at it and going 203, 178. That's not too different from each other. So yeah, I guess they survived at the same rates. The thing that's missing from this, though, is, well, how many were actually in there? So what would I say to this person? We need to know how many total passengers were in each group. To make a claim like that. So, to say they survived at the same rate, that's talking about sort of percentages and proportions. What we have here is raw counts. If you wanted to say like, oh, about the same number of people from first and third class survived, then you got some reason to sort of go with that. But that doesn't tell you much about like the survival rates. I probably already spoiled it by looking down here, but what I want you to think about by yourself here for a moment is how does this table sort of help clarify the ideas that we discussed before? Why is this a better use? And then write down your ideas in that space. Pause if you need to. All right, so moving on now, let's talk about the sort of possibility of discrimination. Someone might look at this, okay? In case you didn't know, third class, those were the poorer passengers. They didn't have as much money. First class had money. Like some of them brought cars onto the Titanic. You know, this is in 1915. There weren't a lot of cars then, or 1912, sorry. So like the fact that some people were able to bring cars onto the boat and like sort of want to, you know, hang out with them and take them over to, another country tells you just about how rich they might be. So you look at this and you're like, wow, 62% of them were able to get off the boat and survive. 25% of the poor passengers, only a quarter of them were able to get off. Like, seems like poor people were sort of at a disadvantage here. And so discrimination might be the first thing that pops into your head. Like, they gave the richies the boats, they were able to get off. But there might be some other things going on here. Discrimination might be part of it, possibly. But what else do you think could be happening? I'd like you to brainstorm that with yourself there and see if you can write down some other factors that we can share when we come into class. Pause if you need to. And to finish it off, a lot of statistics is about probability. And we're going to be talking about probability a little bit like every single week for the rest of the first semester. So I want to just open it up here about, here's a common sort of phrasing of a probability thing. So suppose you chose a crew member at random from the Titanic. Okay, you had a big list of all the crew members' names, and you cut them up and put them into little strips of paper into a hat, and then you reach into the hat, you mix it all up, and then you pull out a name. What's the probability that you choose a crew member that survived? And how do you know? And I'm really telling you, this is not a trick question. Look at that graph carefully, and you should be able to figure out the answer. And why that makes sense would be the answer. So fill in your answer, please. And the last thing before you finish off this video on your own there, I want you to think about some possible questions you could ask. If you threw this display, or the one above it as well, at a family member, a friend, or whatever, what's a question you could ask them that they would be able to answer based off of one of those two displays? Come up with a question there. More brownie points for the more creativity you have in your question. And then come in to talk about that with your classmates as well. So that is it for this first video. I hope you found this enjoyable. Hope you're excited about your first video and getting into the year of statistics. And we will see you in class to discuss some of these questions.